Welcome to this video. Here we are going to apply this Kirchhoff's voltage loop and current loop, and we would like to see how it works. In our previous video, what is voltage loop and current loop? So today we are going to apply this voltage loop and current loop in the circuit, particularly the circuit that contains multiple power supplies. Multiple batteries when we have in a circuit, how to apply Kirchhoff's voltage loop and current loop. So look at this circuit diagram. Here E1 is one power supply which is connected with a resistor R, and E2 is another power supply which also is connected with this resistor R. So we are going to consider this circuit in terms of the loops that being created. So we labeled the point A, B, C, D, E, F and A. This is going to be a complete loop. A, B, C, D, E, F, A. And of this complete loop, there are two individual loops. One is the upper loop, what we call as A, B, C, A, B, E, F, A. This is the upper loop. And I have chosen this upper loop drawing the current from positive terminal to the negative terminal. So the loop I drew is basically an anticlockwise loop. So I can choose it according to my wish. I can choose it as clockwise or anticlockwise. It is my choice. You see that current is driven from the positive terminal of E1, and this current must be entering into the negative terminal of E1, because that is what we know as KCL, Kirchhoff's current loop. Now see the loop that I wrote here, A, B, E, F, A. In this loop, current I3 is flowing through this resistor R, and the loop that I drew anti-clockwise. So you see the loop direction and current direction is same in this case. So if the loop direction and current direction is same, then there would be a positive potential difference across a resistor R. So we wrote that positive PD across R, and this is why the PD across R is going to be the current flowing through it times the resistance. So since the loop direction and the current direction is same, so we can say that current I3 times the resistance R is the positive PD that we got. Look at the loop again. The loop I drew from positive to negative. So completing this loop, the direction of loop is along the direction of current. Since loop direction and current direction is same, there would be a positive PD across the resistor R. So here we wrote the positive I3 R, that is the PD dropped across R. Now we are going to apply Kirchhoff's Kirchhoff's voltage loop, which is basically Kirchhoff's second law. Kirchhoff's voltage loop in this loop A, B, E, F, A. So current flowing through this resistance R in the same direction the way we took the loop. So positive I3R minus E1. Why it is minus E1? Because this current I1 is entering into the negative terminal of the battery. As we complete our loop, we started the loop from the positive terminal, we ended it up in the negative terminal. So it reaches to the negative terminal of the battery, so it is minus E1. That equals to 0. In this loop A, B, E, F, A, no other resistor or power supply is present in this loop, the upper loop that we are talking about. Here there is no other resistor or no other power supply. So we did the algebraic sum of all the PDs and we equated it to be 0. The loop direction and current direction same, so the PD across R is positive. Current entered into the negative terminal of the battery, so it is negative E1, that equals to 0. When we subjected E1, we got the expression to be as E1 equals to E3R. Now if we look at the second loop, the loop right here, B, C, D, E, B. This is the second loop, the lower loop, B, C, D, E, B. So if this is the way we draw the loop, we started the loop from B, it goes to C, then to D, E, reaching back to B. So the loop here again anticlockwise. Again anticlockwise loop I chose. So I can choose anything, any clockwise or anticlockwise. The rule of thumb I need to maintain is if the loop direction is along the direction of current, the positive PD will be dropped across the resistor R. If the loop direction is in the opposite direction of current, then the negative PD will be dropped across the resistor R. If the current enters into the positive terminal, then it is positive. If the loop basically ended up to the positive terminal of the battery, it is positive EMF. If it ended up to the negative terminal of the battery, then it is negative EMF. This is how we algebraically sum all of the PDs and then we equate the expression to be 0. That's what Kirchhoff's second law or voltage loop was. Algebraic sum of all the PDs in the circuit is going to be 0. So look at this loop, the lower loop, loop BCDEB. Here the current I3 is flowing through the resistor as shown in the diagram, but the loop I chose is in the opposite direction of this current I3. You see, the loop I chose started from B, went to C, D, E and getting back to B. So the loop here is in the opposite direction of the current I3. So a negative PD is dropped across R. Unlike the earlier one, there the loop direction was along the same direction of the current, we got a positive PD. So positive I3R. Right now it is going to be negative I3R because the current direction I3 and the loop direction, they are not same, they are opposite. As they are opposite, across R, a negative voltage is going to be dropped. So if we follow this thumb rule, then we will be able to apply this Kirchhoff's voltage loop very accurately. Kirchhoff's current loop, you do understand, whenever current is driven from one terminal, at that terminal the same current will be entering. The current I1 driven from E1 supply and the same current I1 entered into E1, that means the negative terminal of E1. So that is Kirchhoff's second law, Kirchhoff's first law. In Kirchhoff's second law, all the PDs are going to be 0. Here the current and the loop direction is opposite and that's why a negative PD is dropped across R and we wrote negative V equals to negative I3R. Now look at the loop again, B, C, D, E, B. The loop here entering into the positive terminal. When I started taking the loop from B, then from B to C, there was no resistance, no PD dropped. From C to D, there is a power supply. So as the loop is going from C to D, it is going through the positive terminal of the battery, E2. So it is entering into the positive terminal, that's why plus E2. So the equation is negative I3R plus E2 is 0. And when we subjected E2, we got it is I3R. So have you understood the expression, the Kirchhoff's voltage loop that we used and wrote the equations of current, EMF and resistance for both the loops, the upper loop and the lower loop? Just the rule of thumb is when the current direction is in the opposite direction of the loop, it is negative. The current direction when is same direction along the loop, it is positive PD. Positive PD means I times R. You look at the resistor, which current is flowing through this resistor, that current multiplied with that resistor is the PD. The PD is going to be positive or negative, that depends the direction of current and the direction of the loop you considered, either clockwise or anticlockwise. Looking at these two expressions again, E1 and E2, you see the right hand side expression is same. E1 equals to I3R, E2 equals to I3R. That means we can conclude from these two equations that E1 and E2 are same. They have the same EMF, same voltage. And another thing here is, if they have the same voltage and they are connected in this way, it means the current from the battery E1 is not entering into the battery E2. Current from battery E2 is not entering into the battery E1. They are connected in parallel. They are connected in parallel with the resistor R. So the current I3 that we wrote right here is I1 plus I2. The current from E1, current from E2 are entering into this junction BE flowing through this resistor R. So I3 here is I1 plus I2. But since the way we calculated, we wrote down the expressions of E1 and E2, we got to know that E1 and E2 is same voltage. So essentially current I2 here is 0. If I1 has some value, I2 is 0. If you say I2 has some value, I1 is 0. That's the thing. Only one of the power supplies right here working. The other one remains dormant, as they both are having same EMF, same voltage, and they are connected in parallel. Anyways, this is how we applied Kirchhoff's voltage loop and current loop, its first law and second law, and we obtained the expressions for the multiple batteries. One thing you do remember, if the loop enters into the positive terminal, I miswrote here, is I enters to negative terminal. I wrote it is to be, if the loop enters to the negative terminal of the battery, it is negative of EMF. Now let's look at this particular question. We try to solve this question applying this Kirchhoff's first law and second law, current loop and voltage loop. So as you see that this circuit also has multiple batteries, one is E1, another is E2. We have three loops in this circuit: upper loop, lower loop, and the complete loop. Complete loop. When we consider that complete loop, this junction BY will not be included for the complete loop. The complete loop is A, B, C, X, Y, Z, A in the outer circuit that we drew. The rule of thumb, I wrote it at the right corner of the screen. if current direction is along the loop being considered, then PD is positive. Positive PD means positive current times resistance, IR. If it is opposite, then negative I times R. And you understand which direction is anti-clockwise, which one is clockwise. So here we drew an anti-clockwise loop for the first loop, the upper loop. For the second loop, we drew a clockwise loop. For the third one, we drew again an anti-clockwise loop. I mentioned it earlier. You will take the clockwise loop or anti-clockwise loop, that is completely your choice. You just remember, if the current direction is along the direction of the loop, then the PD is going to be positive. If the current direction is opposite to the direction of the loop, then it is negative. If the loop enters, the way you consider the loop, this loop enters to the positive terminal of the battery, it is the positive EMF. If it enters to the negative terminal of the battery, it is negative EMF. That is what we have to keep in our mind, and we have to apply it correctly. So I show you right here that current I and loop direction, when they are in same direction, the PD is positive, means positive IR. So look at this, I, the red one, and the loop direction, the bluer one, is going to be in the same direction, the way I drew right here. If it is in the same direction, we will get the positive PD across the resistor R. But if the current direction is in the opposite direction of the loop, suppose I chose the loop in the opposite direction than the current, then thing is pretty correct, no problem with it. We have to consider the PD across the resistor right there as negative. And when we consider the PD as negative right there, it means it is negative I times R. Alright, so I will request you to write down this rule of thumbs in your copy. Do understand this thing very clearly, do try to remember it, and now apply these things in this network analysis. It is a circuit where we have 3 loops. Before I go to the solving these questions right here, I would like to analyze this circuit. If you understand this circuit thoroughly, you will be able to solve any particular questions that has multiple batteries in the circuit. So the loop 1 is the upper loop ABYZA. So this ABYZA loop, I chose it to be the anti-clockwise. You can choose it other way around, the clockwise, as you wish. Look at this. In this loop ABYZA, current I1 is driven from the battery E1, from the positive terminal. Look at the direction of the current, I1. Alright. Loop 2 that I chose as CBYXC, this loop, I chose it clockwise. And the third loop is the loop that I drew in the outer circuit. This is ABCXYZA. It is anti-clockwise I chose. I mean, I chose it just randomly. You do it yourself and you will get the same expression. You will get the same equation for whatever you choose. If you just follow the thumb rule that I mentioned, I stated, I explained. So if we go for the first loop, ABYZA, we have seen the current I1 to be flowing through this resistor R. So here we have analyzed the circuit, and I already have written the expression right here so that I'll be able to concentrate much on analyzing it, much on making you understand it, how I chose the loop and how I put down the expression right here. KVL, you know, Kirchhoff's voltage loop. If you look at the circuit again, current I1 is flowing through the resistor R. The loop I chose anticlockwise. Look at this. The loop is along the direction of the current. The loop is from positive to negative. As I go away from the positive, I am moving along the direction of the current I1. So here the loop direction and the current direction is same as far as the resistor R is concerned. So I1 times R is a positive PD. I1 times R is a positive PD. I got it right there. Now moving further, look at this junction BY. From the point B and Y, there is a resistor R, and here in this question it is stated current I3 is flowing. So the direction of the I3 again is in the direction of the loop being considered. Check it out. As we move away from positive, we are moving away from positive, we are going towards the negative of this battery. So here in the horizontal junction BY, the current I3 and the loop direction is same. Both are moving towards right. Same direction. So same, positive PD will be dropped across that R. So it is I3 times R. You see what I wrote here. Look at the left side of the screen. Plus I1R plus I3R. Then moving forward, the same current I1 is flowing through this resistor R, which is at the right of the screen, right of the diagram, the vertical one. Why we understood the same current I1 is flowing through this R? The question didn't tell us it. How we understood? Because we applied KCL here, Kirchhoff's current loop. What current has been liberated from the positive terminal of the battery? E1. Isn't it I1? So since I1 has been liberated from the positive terminal of E1, then it is obvious I1 will be entering into the negative terminal of E1. Current leaving from one point is same as current entering into the point. So I1 here is flowing through this resistor R, which is along the junction YZ, along the junction YZ. This is the current I1. So current direction and loop direction again is same. So positive PD is dropped. So plus I1R again. And this loop ended up when we reached to the power supply. So which terminal of the power supply we reached to? We reached at negative terminal of the power supply. So it is negative E1. So plus I1R plus I3R plus I1R again minus E1. This is basically the algebraic sum of all the PDs in this loop ABYZA. It is 0. When we subjected E1, we got the expression as I1R plus I1R means twice I1R plus I3R. So this is the expression that we got for the upper loop, the first loop that we considered here, ABYZA. Look at similarly the second loop, CBYXC. So I started drawing the loop as CBYXC. Sorry. So here again you see the loop I considered and the current being flown, are they in the same direction? So this current I3 is flowing through this R along this junction BY, and this is the direction of the loop because loop has been considered clockwise here. So it is positive PD, positive I3R. The current I2 is flowing through the resistor which is at the bottom of the circuit. Loop is also along the same direction, positive I2R. Where the loop ended up, it ended up reaching to the negative terminal of the supply E2. So minus E2 equals to 0. We subjected E2, we got some expression for E2. Now I advise you right here, pause this video, pause it, and do it yourself for this ultimate loop, the final loop A, B, C, X, Y, Z, A. For this loop, what should be the relationships, what should be the Kirchhoff's voltage loop so that we can get an expression in terms of the batteries, currents, resistors concerned in this loop. When we consider this loop A, B, C, X, Y, Z, A, in this loop, we are not supposed to consider this BY junction. I repeat, BY junction is not going to be considered in this third loop A, B, C, X, Y, Z, A. In this loop, you are not going to consider BY junction. Alright, that means the expression that we are going to get, it is not including I3 because the loop here is the outer circuit, not that inner junction of BY. So you have to consider only the current that is flowing through each resistor and the power supply, as long as you are restricted yourself in this particular loop A, B, C, X, Y, Z, A. So BY will not be included right here. The way when we chose the first loop, we didn't choose the lower loop, loop 2. When we chose loop 2, we didn't choose loop 1. We didn't consider loop 1. And right here, when we are going to choose loop 3, A, B, C, X, Y, Z, A, we are not going to choose any of the individual loops right here. So this BY junction is going to be omitted from our consideration. So I hope you paused the video, you did it yourself. Now check it out. This current I1, as we started the loop from A, flowing through this resistor R. So as I go with the loop, current direction is along that loop. So it is positive PD. I1 R is positive. You see positive I1 R in the expression. So I1 R is there. It is positive I1 R. Then as we go down to the loop, it entered into the positive terminal of the E2. So plus E2 is here. Then again, as we move, we see that I2 is entering into the negative terminal of the E2, but our loop is in this opposite direction. So I2 and the loop direction, they are not in the same direction, they are in the opposite direction. As they are in the opposite direction, a negative PD is going to be dropped across it. It is negative I2R. Look at this expression, check it out. And finally, when it reaches back to this point A, it is going through the negative terminal of the battery E1. So it enters to the negative terminal of the battery E1. Minus E1 equals to 0. So this is how we subjected E1 and we got the expression to be like this. All right. So if we understood these three loops, how we analyzed them, how we got the expression individually for each of the loops, then it is very easy for you to crack this particular question they asked. They asked a very simple question right here. But once you understand all the details of this thing, when the multiple batteries are given in the circuit, then doesn't matter what is the question, it is going to be a simple for you, a simple problem for you. So check it out. They asked us to find out the relationship between I1, I2 and I3. So it is quite obvious that current I1 driven from E1, current I2 driven from E2. How we understand I2 is driven from E2? Because they wrote I2 which is entering into the negative terminal of the battery. If I2 enters to the negative terminal of the battery, that means this I2 has been liberated from the positive terminal of the battery. So I1 plus I2 equals to I3. This is Kirchhoff's current loop, first law. Look at this second question. They gave the loop as BC XYB. So BCXYB they gave the loop as, and we chose the loop as CBYXC. All the same, we chose it as clockwise, they gave it us to as anti-clockwise. Doesn't matter. If we follow that thumb rule, we are going to get down to the same expression. Check it out. I drew it right here at the bottom of the screen. BCXYB, I3 is flowing through this resistor R, I2 is entering into the negative terminal of E2. So when I choose the loop from B, then it is entering to the positive terminal of the battery. So it is plus E2. Then the loop is going towards right, but current I2 is moving towards left, opposite direction. So it is negative I2R. Again, the loop is going towards B, right here towards left, but current I3 is towards right, towards Y. So again, negative I3R. So E2 expression right here, what we got is same as E2 expression right here as we got considering the clockwise loop CBYXC. So you choose a clockwise loop or you choose an anti-clockwise loop doesn't actually affect the final expression. The final expression remains the same. If you follow this rule of thumb that current direction and loop direction, are they in the same direction? Then obviously positive PD will be dropped across the R. Opposite direction, negative PD will be dropped across R. As we choose the loop, loop is entering to the positive terminal, then positive EMF, negative terminal, then negative EMF. We will be algebraically take the sum of all, we will equate it 0. And then finally, we will be subjecting one particular variable, so left hand side, right hand side equation will be formed. All right. Here, the third question, they just simply asked us what would be the relationship between E1, E2, I1, I2, and R in this outer circuit loop that we chose in loop 3, A, B, C, X, Y, Z, A. So it's all done. I hope you understood it. If you have any particular question, you can ask me. I would like to tell you to watch this one over and over again and take the note of it. It is an educative class, so you have to take the note of it. It is not some song or some motivational speech that you will just hear without noting it down. Thank you very much for watching this video. Thanks a lot.